Hello to everyone. Hope all of you are doing well. So today we have a session on F450 drone. I will talk about how we can make a drone at very low cost using F450 drone, and by choosing the certain motor or selecting the certain motor and a battery flight controller, and we combine those, we assemble those and make a drone at very low cost of our own at home. So we will talk about this. So let me introduce myself. I am Ashwini Kumar Sinha. I am tech journalist at EFY, and I have done a lots of project. You can find my project on electronicsforyou.com, and it's video proof on Tech Drive. And you can also find some of my project on EFY magazine as well. I have done lots of project on IoT robotics. So if you want to make that, you can visit the electronicsforyou.com. And so let's start the session with introduction to the frames of the drone. There are various frames in the drone that you can find in the market. So which one you have to select for your drone so that you can make it at low cost and easily, that is very easy to use, that is very easy to assemble. So there are lots of drone frame size and types, H copter or X copter, quadcopter or hexacopter. But here we will talk about the quadcopter, and we will talk about some various drone from that are common in the market. Like you can find those drone frames easily at online stores. So these are the list of very common drone frames. Here is a QAV 250. QAV 250 is a racing drone frame. You can find this drone frame in uh, three material types, like one in carbon fiber, or another in glass fiber, and there are plastic as well. So QAV 250 is a small drone frame. It is generally used in the racing drone. So if you use the QAV 250, then you have to use a high RPM motor, because the QAV 250 drone frame is a smaller one, and you have to use the 5-volt propeller with QAV 250. So for 5-volt propeller, it is necessary to you have a high amount of RPM for that, so that it can generate the thrust to move the drone towards the sky. So if you use the QAV 250, you have to use a good quality of motor, a good quality of ESC, and you have to also make the drone a little bit lighter, so that the drone can easily lift up and fly, and it is easy to control. So QAV 250 is really used for the racing. Another drone frame is for F450. F450 is little bit bigger in size. It is DJI F450. So it is little bit bigger in size, and it is easy to build, and it is easy to assemble. So here I am using the F450 drone. The reason behind the using this, because with F450 we can use the 1000 kV motor with 10-inch propeller. So with 10-inch propeller and 1000 kV motor, that is enough to lift up the drone in the sky and fly. Uh, if we use the smaller drone frame than F450, like QAV 250, then we have to use some costly motor as well, and some costly uh, flight controllers for that. So that's why I'm trying to make the whole drone in very low cost. That's why I'm using F450. I will show you the pic of F450. Let me. So here you can see the F450 frame. Let it open. So here is a F450 frame. So in this frame you will get a power distribution board in the frame as a part of it. Like the power distribution board is in the drone frame. It is built-in power distribution inside the drone frame. So you need not to pay extra rupees to get the power distribution board for the drone. It is already there. You have to just connect the wires on the drone frames, connect the ESC wires on the drone frames, and it, it act like a power distribution board for your drone. So you can see these points are for the connection of ESC. So you can solder the ESC to the drone frame on it, and you need not to buy any power distribution board from the market, because it's already there in the frame. So another drone frame is ZMR 250. ZMR 250 is also a racing drone. It is also smaller than F250, and it also required a high RPM motor and 5-inch propeller to fly because of its smaller size, like QAV 250, and Martian 2 is also a racing drone, TBS 500. So these are the common drone frame, but except of F450, all these are smaller in size and usually used for the racing drone. So if you want to make a racing drone, you can use any of these propeller except of F450, any of these drone frame except of F450. But if you use F450, you can make a drone at very low cost. So that's why I'm using here F450 drone frame. As you can see here in the pic, it is the F450 drone frame. QAB 250, I have also made some drone with QAB 250. Let me share you the image. So here is the QAB 250 frame, but this frame requires a high RPM motor, higher kV of motor, so that you can lift the drone up in the sky. That's why I'm not using here right now in this DIY. But you can see there in the QAB 250 drone frame as well. So this is all about the drone frames, various drone frames that is common in the market that you can easily find it on any online store. So here we are going to buy the F450 drone frame for our drone. Next we will have to select the flight control. There are lots of flight controller available on the market with different functionality. So here I am using I have made the F450 drone with two flight control. One is KK 2.2 flight controller, another one is CC3D open parrot flight controller. So you can use any one of them for your F450 drone. Reason behind selecting this flight control because is these flight controller are a little bit cheaper and you can easily find in the market in any online store at very low cost, while rest are very expensive one, and though they have extra functionalities like altitude hold and many other uh, another functionalities, but we don't need here. We just want to make a simple drone that we can fly by own at very low cost. That's why we are using the CC3D and KK 2.2 flight controller. So you can use any one of them. You can either use KK 2.2 or use CC3D flight controller. But if you have the PC for setting up the flight controller, then you have to use CC3D flight controller. But if you don't have any PC or any laptop to install the software or do the settings inside the flight controller, then you have to use the KK 2.2 flight controller. Why? Because KK 2.2 flight controller didn't require any type of a connection with the PC. Do not require any PC or laptop for its setup. You can do it manually by the hand. You can get a LCD screen and some buttons to do the settings for your flight, like here. I will show you. Like here in the pic, you got a LCD and some button here. So using this button and using the graphical interface, you can easily set your flight controller to make your drone fly in the sky. Uh, Rather than using the PC for setting up the flight controller. So if you don't have the PC access to the PC or any laptop, then you can use the KK 2.2 flight controller and make a drone easily at home without use of any PC and much time in setting up the flight controller or operating the firmware and other things. So here for F450, we can use either any of we can choose KK 2.2 or CC3D, any one of them. You can get the KK 2.2 flight controller in around 1,500 or CC3D in 1,200. Rest are very expensive. Rest are of 5,000 or 8,000 or 6,000, something like that. So I'm not going to invest so much money on this flight controller because we just want to make the drone at very low cost. So next is the radio receiver. There are lots of radio receiver you can find in market for the drone, but here we will use the simple one that is easy to use and that is easy to install and that is low in cost as well. So here are the list of few uh, few transmitter and receiver. One is CT6B flash sky radio receiver. It is 6 channel radio receiver. So you can we are going to use this radio receiver for our drone because this is low in cost and easy to install with the drone. And you can also use FS I6 flash sky radio receiver, but this is little bit expensive, but this is better than the CT6B flash car radio receiver, and we'll also get an LCD screen on the radio receiver that will show you the battery percentage and all other details of the flight and the receiver. So you can choose either of them, either CT6P or FSI6 flash car radio receiver. Here I am using CT6P flash car radio receiver. Another one is Radio Link 89 2.4 gigahertz radio receiver, but it has 9 channel, but here we are taking help of only 4 channel for controlling the drone, so we don't need it so much expensive flight controller here. So next is motor, selection of the motor. So we want to make the flight control low, our drone is very low cost, so we can easily get 1000 kV motor at very low cost, nearly 1000 rupees or 2000 rupees. So this is the model of the, this is the name of the motor, model name of the motor AA2212. I will show you how this look like. This is the AA2212 motor. This motor have 2200 kV rating, but in F450 I have used 1000 kV motor, because 1000 kV motor with 10-inch propeller is enough to lift up the drone easily, and we can fly using 1000 kV motor or 9900 kV motor. So you can also get some good quality of motor like Racer Star BR2830 or MT2212 or BR2212. These are the 9000 between the 9000 to 1000 kV motor, and these are the good motor. But with this motor you have to also use the good ESC to get the maximum output and to get the efficient output from the drone. And but here we are using the 82212 motor because it is easy, because it's lower in cost, and we can make our drone at very low cost, and easily we can make it at our home. Next is the assembling of the drone frame. So first we have to do is assemble the drone frame, and then we have to solder all the ESC on the DJI drone frame, and then you need to calibrate the after soldering the everything, and then you have to connect the motor, and then you have to calibrate the ESC of the drone. So here calibrating the ESC for the drone is one of the important part and one of the toughest part as well, because when you miscalibrate the ESC, like you don't calibrate the ESC properly, then some of the motor might run speedily than other, and makes the drone tilt toward one side and might get crashed. So these things are often happen during the ESC calibration. So if you're using the CC3D flight controller, then you can get the ESC calibration during the setup of CC3D flight controller. But if you're using KK2.2 flight controller, I have found that there is a problem in calibrating the ESC using the flight controller board by itself. So I have used another method to calibrate the ESC. What I have used is the radio receiver and the transmitter to calibrate the ESC. Simply plug the ESC to the throttle pin of the radio receiver, that is channel number 3, and then put the remote stick, throttle stick, to the max position, power on the ESC by LiPo battery, and then wait for a beep. The motor will beep ting ting for the 2 times, something like ting ting, something like this, and for the 2 times, and then you have to put your throttle stick to the minimum position, like downwards to the minimum position, and then again you will hear a ting ting 2 voice, 2 to 3 beeps, and then your ESC is calibrated. Now you move the throttle stick slowly. You can see the motor start rotating, and when you put the throttle to the max, the motor start rotating rapidly. But make sure that while doing the ESC calibrate, you should not uh, attach the propeller with the motor, because if you do the ESC calibrating with propeller attached on it, then there is a chances of getting some accident, or some your hand might get chopped off by the propeller. So be careful, don't do the ESC calibration with the propeller installed on the motor. And next thing you have to also take care of, like when you make a drone, then you have to take care of the rotation of the motor. Front motor of the drone must be rotating clockwise, and then next second motor in anti-clockwise, and then clockwise, and then anti-clockwise. So in this way you have to figure out the rotation of motor. If you found any rotation of the motor is in reverse direction, then you can exchange the connection wire of ESC with the motor, and by swapping that you can reverse the connection, the rotation of motor. Like you can see here, the 3 wires coming out from ESC and 3 wires from motor. So these 3 wires is connected to the ESC. Suppose that your this first drone is supposed need to be moved in clockwise direction, but this motor is moving in anti-clockwise direction. Then you have to just swipe any 2 wires, swipe the connection of any 2 wires, and the rotation of motor get reversed. So you have to do this. You have to keep in mind that first motor move is clockwise, the second motor must move in anti-clockwise, and then clockwise, and then anti-clockwise. These 2 motors should be in anti-clockwise, and these 2 motors should be in clockwise direction. So you have to check this. You have to keep this thing in mind, otherwise your drone will not fly. But one more thing you might face, if you calibrate the ESC one by one, then there is a chance of getting some ESC not calibrated property like the others, like some motor move rapidly than the another, or some motor move slowly than the another. So if you want to do a perfect calibration, then you have to do one thing. Let me tell you. You have to take a board, and then you have to make a connection of channel number 3 signal pin of the radio receiver, and then connect all the ESC with the ESC signal pin to this radio receiver channel number 3 signal pin. Suppose that we have 4 channel number. So these are the 4 pins of ESC, signal pin of ESC. So we connect all those 4 signal pin of ESC to the channel number 3 of the radio receiver. So all ESC will get the signal from the radio receiver at the same time. And next, what you have to do that you have to connect the ground pin of the radio receiver to the ground pin of those ESC, and positive pin of the radio receiver to the positive pin of the ESC. Now what you have to do is turn on your transmitter, keep the transmitter throttle stick to the max position, then power on the battery, and then you will hear a beep sound from all those motors at the same time, and then put the throttle stick to the downwards, and then again you will hear a beep sound from all those motors at the same time. And then when you move the throttle stick towards the maximum, then all the motor will move at the same time with the same speed. So this is how you can calibrate all the ESC easily with the same speed. So this is the calibration of ESC part, that is a little bit tough, but I hope you can do it easily with this method. And next, you have to set the drone layout. In KK flight controller, you have to set a drone layout, like what type of drone you are using. So you got a menu button here in the KK flight controller. these menu buttons. So you have to press the menu button, select the drone motor layout, then you have to select the F450 X quadcopter X mode, and you have to set the drone motor layout according to your door frame. Like here I'm using the X copter, so you have to select the X copter. Next, you have to calibrate the radio transmitter receiver. Here you have to go to the flight controller menu. You have to use these buttons, and you have to go to the transmitter slider menu, and in the transmitter slider you have to check the all the value received by the receiver should be the in ideal position, that is either in 0 or towards 0 or 1 towards 0 1, not greater than 5 or minus or greater than -5. So you have to check the value is around 0 or 1, 0 or 1. So if you don't find any stick value around 0 and 9, it is somewhere around 15 16. So you have to trim the remote of your drone, and bring the value back to the 0, so that radio receiver will get all the value 0 at starting time. If the value is not 0 there, then flight control thinks that you are moving your throttle or yaw or pitch sticks, or moving your pitch sticks. So you have to check the values and trim the radio transmitter and receiver accordingly. So after doing this calibration, your drone is ready to fly. You can arm your flight controller using the remote control, and then your drone is ready to fly. You can fly the drone. You have to connect the batteries, and you have to make all the connections with the flight controller. And one more thing, you have to do the ACC calibration before taking the flight. Before flying your drone, you have to go to the menu and then select the ACC calibration. Then you have to put your drone on the flat surface, and then you have to press enter, and then wait for a few seconds, and don't move the drone during this calibration. So when the calibration drone is getting calibrated, you are ready to fly the drone. So now came on to CC3D. What I found that a lot of people have problem with the arming of CC3D flight control. They can easily do all the settings and do all the setup with CC3D flight controller, but at the end they are not able to fly the drone. They are not able to arm the drone to fly it. CC3D didn't accepting the arming command from the remote. I have read lots of comments and lots of error regarding this on the internet, and from the vendor where I have bought the CC3D flight controller, they have also getting some complaint that these boards are not working, these boards are faulty, and there are lots of complaint about the CC3D flight controller. And I have also bought the CC3D flight controller, and I've also got the same problem, like it is not arming. So I have tried a lot, and I figure out where the problem is. Actually, when you try to arm the CC3D flight controller using the sticks like throttle stick, yaw stick, or pitch stick, then it will not fly. It will not arm. I don't know what is the reason behind this, but when I change the arming setting to another accessory channel, like you got a rotating button on your remote control, that is channel number 6 or accessory 0, then when I select that thing for arming and move the that rotating button to the max, and then the flight controller get easily armed. So this is the problem behind the CC3D flight controller. So if you face such problem, then change the arming setting to the accessory 0 or accessory 1. Not arm it, not try to arm it using the sticks, otherwise it will not arm. I don't know what is the reason behind that, but a lot of people are having problem with this arming on CC3D. So that's all for here. Hope you have a lot of learning from this session. You can go to the expo and check out some interesting products there. Thanks a lot.